Okay, welcome back, everyone. So, continuing on to section 2.1 is this next example, example 5, where we're going to find the equation of the tangent line of a specific function at a point x squared. So, what we're really doing is here is hopefully we're going to be finding an equation of a tangent line, meaning like y equals mx plus b. And the line we're really finding is think about kind of 1.6 where look some type of graph like this, right? Some type of graph like that. And we're trying to find, what's a different color, right? We're at a specific point on the graph, right? And we're trying to find some tangent line at that point, right? That's what we're going to try and find. So we're trying to find the tangent line at x equals 2 of this function, right? So that's kind of the goal, right? And we can do that. So there's really a step-by-step process of how to do this. So example, the first thing we want to do is find the derivative of this function, right? Because that's what a tangent line is, a derivative. So step one, find derivative. So here I have f of x equals 3x squared minus 2x plus 4, right? And I just want to find the derivative of that. So f prime of x is going to be 3 times 2x minus 2 plus 0. Okay, so this becomes 6x minus 2. All right, so luckily, if you've noticed already, this is the same problem as above. So we have all these steps already, but I just want to make sure we go through all the steps when we apply this to a different problem that we don't have everything already. So second thing I want to do is plug in x equals 2 into this derivative. So same exact thing as the previous problem. So here we have f prime of 2. Oh, you know what? I'll use a different color. We have f prime of 2, and that's going to be 6 times 2 minus 2, which is 12 minus 2, which is 10. The same exact thing that we got before. So f prime of 2 is 10. Okay. So here's where we move past example 4, and we're not getting into different territory. But next thing I want to do, remember, like I need to find an equation. And so in order to find an equation of a line, I need to use a point. So third thing I need to do is I need a point. Okay. So I need a point, meaning like X, Y. Oops, let me rewrite that. All right, I need that point. So I already have X equals 2. So I'm gonna plug that in f of x to get my output. So so luckily we did the work above for f of 2, but let's go ahead and do it again, right? So f of 2 is 3 times 2 squared minus 2 times 2 plus 4, which is 3 times 4 minus 4 plus 4, which is 10. Actually, no, it is 12. Sorry about that. It's going to be 12. So f of 2 equals 12, and that gives me a coordinate point 2 comma 12. Okay, so now I have a slope, I have a point. Now I could just use point slope formula to get my equation. So lastly, find equation. Okay, let me kind of move this off to the side, but find equation. So we call it the point slope formula is y minus y1 equals m times x minus x1. So I have my point and I have my slope. So let me go ahead and plug those guys in. So this is y minus 12 equals 10 times x minus 2. All right, point slope formula. This is from our algebra review and just, some basic algebra concept. And now it's just we go ahead and find our y equals mx plus b. So this becomes y minus 12 equals, going to distribute into 10. So 10x minus 20, right? I distributed into 10, and I'm going to add 12 to both sides to get that y by itself, to get my y equals mx plus b. So 10x minus 8. And that is my equation of a tangent line at x equals 2. And that's really how you do it. So if in the homework you're given find the equation of a tangent line, just do this four-step process. Find a derivative, plug in that x value, uh, plug in the x value into the original to get that xy coordinate point, and then use a point slope formula or the slope intercept formula to get your equation. But it's really the same like 4 steps. Okay, so apply that to the homework. So example 6 is if y equals 2x squared minus 7, find dy over dx. Evaluate at x equals -1. I'm not really too much of a fan of this notation. I really just, it means the same thing, but I personally just like when it says, like f prime of -1. All right. So that's what I kind of prefer. But let's go ahead and do it. So, I guess I'll change this to f of x equals 2x squared minus 7, right? Just changing a couple annotations just for personal preference. But same thing, I want to find the derivative and then plug in -1. So f prime of x is going to be 2 times 2x minus 7, which is just 4x minus 7. Oops, sorry, a little typo there. This is actually 0 because the 7 is a constant, so it just goes away. So it's just 4x. And so f prime of -1 is going to be 4 times -1, which just equals -4. And that's my answer. Okay. Excuse all the, let me clean up this a bit. But yes, I don't like that annotation too much. Just f of x equals 2x squared minus 7, and then f prime of -1. Finding it at -1. Okay, so that is some evaluation. Now let's go into some word problems with some applications, mainly interpretation. All right, there's a couple of questions like this on the lab, so try to understand it here, and then, so once again, I'm not a big fan of this interpretation. So what I want to rewrite this as p prime of 60 equals 2. Okay, just want to rewrite it like that. Let's go ahead and read this through. So it's kind of a business question. Suppose for a particular item, p of x relates to profit in thousands of dollars to the amount x in thousands of dollars spent on advertising. We want to interpret both p 60 equals 40 and p prime of 60 equals 2. So the first one, p of 60 equals 40, that's just like an input output kind of question, right? So the first one, the expression p of 60 equals 40 means a profit of how much? A profit of not $40, but $40,000, right? Because we're talking about thousands of dollars, means a profit of $40,000 will be earned if how much is spent on advertising? If not $60, right? That doesn't make sense. If $60,000 is spent on advertising, if $60,000 is spent on advertising. Okay. So that's what this one means, right? We're not talking about derivative yet. It's just input output. What is the question telling you? How can you interpret it, right? So second question is now we want to talk about the derivative at 60, right? The derivative at 60 is 2. That instantaneous rate of change, that slope, right? All that good stuff. So what this means is when we're talking about profit and things like that, what this means that P, I'll write this, the expression P prime of 60 equals 2 means that the profit will increase, will increase by $2,000, right? We're talking about thousands of dollars, will increase by $2,000 if an additional 1,000 is spent on advertising at the current advertising level of $60,000. Okay, so that's what P prime of 60 equals 2 mean. That if we spend another additional $1,000 at the current level of $60,000, then the profit will increase by $2,000. So how do I know about additional 1,000 things like that? Well, we're kind of remember that this is a slope, right? The slope of that tangent. And what does the slope look like? Well, the slope is rise over run. So in this case, it would be 2 over 1. But we're also talking about $2,000 over one um over $1,000 spent on advertising. So that's how that kind of works out with the slope. But just if that's a little too complicated, right? In terms of graphically, what it means is that if we just spend an additional $1,000, right, one more, then this will be an additional $2,000 in profit if we're at that current level. But okay, so here's another example here. All right, so this says the function r of x equals 85 plus 7.130 square root of x between 0 and 15 indicates that the monthly revenue r in $1,000 depends on the amount of dollars x spent on advertising each month. So how much will the monthly revenue be expected to change if the monthly expenditure on advertising were to be raised from its current level of 6,000 and 6,001? Find the marginal revenue. And what is a revenue when the amount spent on advertising is $6,000? Okay, so how do we go about that? Okay, so for part A, right? Marginal revenue. So marginal revenue, when we talk about marginal stuff, what that really means is finding the derivative, finding how much it would be for the next one. So much like for the previous question where it was one additional, right? We're kind of thinking along that same lines. And that's what the derivative tells us in these application problems. So for part A, what we got to do is find the derivative. Okay, so that's what we got to do. So we have R of X equals 85 plus 7.130. And what I can do is rewrite this as X to the 1/2, right? Because that way I can use a power rule. So this becomes X to the 1/2. Okay, so I want to take the derivative of this. So R prime of X, this is going to be this 85 just a constant, so it becomes 0. So 0 plus 7.130 times 1/2 X to the negative 1/2. Right? This guy drops down. I subtract 1 from it. Okay, so what this ends up being is 7.130 times 1/2 becomes 3.565 x to the negative 1/2. But then I want to make this guy positive. So what I'm going to do is bring it down to the bottom. So it becomes 3.565 over x to the 1/2. Okay, but I know x to the 1/2 is just square root of x, so it becomes 3.565 over square root of x. Okay, so that is the derivative, but once again, to find the marginal revenue, I can just evaluate at this 6,000 in order to find the marginal revenue to the next dollar. So what I need to do is just plug in 6,000 into this. So 3.565 over square root of 6,000. And if I calculate this out, it should be 0.0460. Okay, so what does this mean? So recall that this is in thousands of dollars as well. So what this means is the monthly revenue should increase by approximately $46 if the advertising budget is increased from 6,000 to $6,001. Okay, so if we increase the advertising budget from 6,000, we increase that $1, like one additional dollar, the monthly revenue would increase by $46. Right? Remember, we're talking about in thousands. So that's why this guy moved over 3 times. 1, 2, 3. That's why it's $46. Okay. So that's part A. So that's our marginal revenue. Little taste of that before we get into that more. So what is a revenue when the amount spent on advertising is $6? So now we don't want marginal revenue or anything like that. We just want to know what is a revenue when we spend $6,000 on advertising. So coming down here a little bit, right? But part B, we just got to evaluate at the function. So I'm going to plug in 6,000 into the original, this guy right here, and figure out what my revenue would be when 6,000 is spent on advertising. So this would be 85 plus 7.130 times the square root of 6,000. Okay, well, this ends up being like 85 plus something like 552.287, which ends up being like 637.287. Okay, so what does this mean, right? Well, this is the revenue when $6,000 is spent on advertising. So the revenue is approximately, I'm abbreviating a bit, $637,287 when advertising budget, oops, when the advertising budget is $6,000. Okay, so part B is just straight up input output, and then part A is using the derivative to find the marginal revenue. And marginal is the same thing with revenue, marginal profit, marginal cost. So giving us a little prelude to that. But that's it for this section. There's some extra practice problems here in case you want to try them out with your derivatives. It's up to you. But other than that, see you next time. Thank you. Bye.